Alright, so solving linear inequalities is exactly like solving linear equalities, aka equations, um, with one exception, and that is you have to remember to flip the direction of the inequality sign if you happen to divide both sides of the equation in the process of solving it by a negative number. Okay, so I've got some examples where that happens, and I have some examples where that doesn't happen. So I'll just show you, you know, you'll kind of know what to look for. Um, but yeah, let me just kind of take you through the process here. So don't be freaked out by these weird-looking signs, these inequality signs. You just follow the same basic steps that you've been learning with algebraic equations, this whole time. So let me let's give this one a whirl. So I've got 5x minus 30 is greater than or equal to 10. Um, so I want to isolate the variable. I want to get x by itself so that it will become obvious what x is greater than or equal to. Right now, 5 times x subtracted by minus 30 is greater than or equal to 10. But we're not sure how x relates to this whole thing yet. So we want to get x by itself, and we go in the reverse order of operations. So I've got x being multiplied by something, and then something being subtracted here. So when I'm following the order of operations, I would do multiplication before subtraction. But since I'm solving an equation or an inequality, I go the other way. So I start with the addition or subtraction. I'm subtracting 30 here, so to undo that, so to speak, I'm going to add 30. As negative 30 plus 30 is 0, so that would just disappear, and I have to do whatever I do to one side of an inequality, I have to do the other side of the inequality, just like with equations. So I'm going to add 30 to the other side too. It's a 30. So these guys are gone. All that's left on this side is 5x. So we've got 5x is greater than, so 10 plus 30 is 40. Now x is being multiplied by 5, so I want to get x by itself. Let me actually rewrite this up here. I want to get x by itself. So I need to divide by this side of the equation by 5. So when I do that, all I'll have left is x. So I'm going to divide the other side by 5 as well, so that the inequality remains true. So I've got x is greater than or equal to, okay, then 40 divided by 5 is 8. So that's my answer. I could graph it, on a number line where I've got the number 8, and I draw an arrow like that, and it would be filled in the end because it could equal 8, and anything greater than 8 also counts, as an answer. So it would look something like that. I'm just going to leave the rest of the answers in inequality form like that. X is greater than or equal to 8. So let's keep going here. So we've got 40 is less than negative 6 times x plus 2. So we want to get x by itself. So let's start undoing this, unraveling this. I'm going to subtract 2. I'm going to go back to blue, I guess. Subtract 2. So I'm going to do that to the other side of the equation. Now, I'm subtracting numbers, so there's negatives here, but you only flip the sign if you're multiplying or dividing by a negative number. So we're fine so far. So plus 2, minus 2, these are gone. So 40 minus 2 is 38. So we've got 38 is less than negative 6 x. And okay, now we want to get x by itself, so we're going to divide by negative 6. Okay, so ding ding ding. This is where if you divide or multiply both sides by a negative number, which is what we're doing to get x by itself, you flip the sign. So I'm going to write this out here. So this less than sign will actually flip around and point the other direction. Oops. struggling to draw. Here we go. It's gonna look like, yeah, close enough. So 38 divided by negative 6 would be negative 6 and 1/3. I got that. 6 goes into 36 6 times, and then when you do that, you've got 2 left over to make it 38. So your remainder would be 2 out of the 6. 2 out of 6 reduces to 1 out of 3. So, and this is negative. So negative 6 1/3 is greater than x. So we flipped the direction of the sign because we divided or multiplied both sides of the equation by a negative number. So there we go. All right, how's it going for you so far? Pretty logical, I hope. You know, nothing to panic about. Okay, so 10 minus 3x is less than or equal to 5 6x plus 20. So we got x on both sides of the equation, so you know we can deal with that. Let's decide what side of the equation, or the inequality, excuse me. I said equation before too. These are all inequalities, not equations. Inequality. It's saying that the sides of the inequality sign are not equal to each other, and they're not equal to each other in certain ways. You know, this side of the equation is greater than or equal to this side. This side of the equation is less than the value of this side, etc. Okay, so let's decide that x will be on this side of the inequality. So I'm gonna get that 10 out of there. Subtract 10. So we got negative 3x is less than or equal to 5 6x. 20 minus 10 is 10. Now let's get this x over on that side too. So we're going to subtract 5 6x from both sides. Okay, so I've got I'm gonna do this over here. Negative 3x minus 5 6x. So I need to have a common denominator here. So I'll make this negative 3. Oops. I'll make that into something out of 6. So they both have a denominator of 6. So so that would be negative 18 6. You know, so negative 18 divided by 6 would be negative 3. So negative 18 6x minus 5 6x, and then we've got a negative number, and we're reducing it even further by 5. So this would actually be negative 23 6x, and we could make that into a mixed number. Let's say, how many times does 6 go into 23? Well, it goes into 24 4 times, so it would go in 3 times. So that'd be 18, and there'd be 5 left over. Which would just kind of, that's where we started off with. So it would just be negative 3 and 5 6x. I guess I took you on a wild goose chase. Negative 3 and 5 6x is what we have left over here. Okay, so what's going on here? So we have negative 3/5 x is less than or equal to, and then we had just 10 left over on the side of the inequality. So okay, so actually no, let's leave it as negative 23 6, because last step I need to divide by negative 3 and 5 6 so that x can be by itself. So I'm going to divide both sides of the equation by negative 3 and 5 6. So okay, first the sign will flip because I'm dividing or multiplying both sides of the equation, or the inequality, by a negative number. So this is going to turn into a greater than or equal to. And by the way, if you if you divide or multiply by a negative number and the sign flips, and then later on you divide or multiply by another negative number, then flip the sign again. You know, just however many times you do it, flip the sign. Okay, so last step here. So these go away, so it's gonna be x is greater than or equal to something. So I need to divide 10 by negative 3 and 5/6. So actually, I'm going to leave that as an improper fraction. So we can do 10, 1, 10 over 1. And then to divide by a fraction, you can multiply by the reciprocal. So I'll just do 10 over 1 times 6 over negative 23 is what I'll do. Yeah, because this negative 3 and 5/6 is negative 23/6. Negative times 6 over negative 23. So that would equal 60 over negative 23. Which, let's see, 23 is a prime number, so we can't reduce that. We could turn it into a mixed number, though. 23 goes into 60 2 times. It's going to be a negative number 2 times, so that'd be 46. And then there's 14 left over after that, so 14 23rds. So x is greater than or equal to negative 2 and 14 23rds. Lots of fractions flying around today, but I thought this might be a little too boring. You know, if all we're doing is the same kind of steps of solving linear inequalities as solving linear equations. So you know, that's a little extra for you. So x is greater than or equal to negative 2 and 14 23rds. You can turn that to a decimal. You know, whatever. I like fractions, I guess. All right, and why don't you try this one? Negative x over 7 plus 3 is greater than 8. All right, good luck.